Okay. So today we want to be looking at functions in MTH, which is for your 100 level. Okay, so if you are talking about function, pay attention that you see the best way to understand the meaning of the word function is that it is a rule that assigned to each element, a rule that assigned to each element x in a, let me say, in a set called D to exactly one element in another set called what? Called E. Let me give you an example. This is the best way to understand the word function. Check this thing. A function is like, let me say, a machine whereby whatever you input into this machine, this is your input, determines, sorry, this is your input. Whatever you input into this machine will give you your what? Your output, which is f of x. This is your output. For example, if I have a function which is stated as square root of x minus 2, if this is what the machine is processing, if I input 4, if I put 4 as the input, you know, the machine will process it as square root of 4 minus 2, and that's 2 minus 2, and what will be the output? 0. This is what we call function. All together? Exactly. So just observe it as a machine, whereby the input determines what the output will be. Okay. Now pay attention. Look at this set. Let me call this a set D. And let me call this another set. Let me say this set I'm having here is set E. Okay. This is a function relating this set to this set F. Now pay attention. Remember that I told you that a function is a rule, a particular rule that assigns one element in one set to exactly one element in the other set, f of x. For example, let me say I'm having A in this set D. A function is this rule that we assign A to exactly another element in this set, which is what? F of A. Altogether, it can relate another element here, so another element here. This is what we call what? Function. Okay, this is what we call what? This is what we call function. Now, pay attention. Let us now go into the main work about the domain of a function. Now, pay attention. You see, if a function, pay attention, if a function is given to you as a formula, if a function is given to you as a formula, and they did not tell you the domain of the function, now pay attention. What do we now call the domain? They gave you a function in terms of what? In terms of a formula. I'll give you an example. And you were not given the domain. Now pay attention that what? The domain of such function. The domain of such function is what? What is the domain? The domain is what? Is the set. The domain is the set of all numbers for which the formula they gave you, is defined. Exactly. If they give you a function in terms of a formula, just take note that what? The domain of that function is the set of all numbers for which the function is what? For which the function is defined. Let me give you an example. Let's say, for instance, that you were given f of x to be equal to, check, they gave you f of x to be equal to square root of x plus 2. And I asked you to find the domain of the function. Now, pay attention. Remember that if I have a square root, remember that what? Square root is only possible for positive numbers and not negative number. If you find square root of negative number, that will not be a real number again. It will be going to a complex, the complex set of numbers. Now, it means that what? The domain of this function is that what? It will be what? All values of x for which x plus 2 must be greater than or equal to 0. Pay attention. For this square root to be possible, what is inside this square root? I'm talking about square root now. What is inside this square root must be greater than or equal to what? 0 for it to be defined. Okay. From here, it means that I'll be having x greater than or equal to minus 2. So how do we now write the domain? It means that for this particular function to be defined, it is true for all value of x for which that x is greater than or equal to -2. You see, if you disobey this rule that is here, this function will not be defined again. So how do we now write the domain? Now, to write the domain of this function, pay attention from what is here, the values of x for which this function is. So I can write my domain this way. I can write it in different ways. So look at what we can use to write the domain. Look at this set, -2, infinity, close interval. Now check. What's the rule behind this thing? Now check. Whenever you have something like equal to with your inequality, you'll be using this type of brackets. Now, since we are looking at s greater than -2, it means greater than -2 and so on, up to infinity. And whenever you are using infinity or negative infinity, we use this type of bracket for it, square bracket. So since we are having greater than, what do we have? So we say -2 is our starting point. You understand? -2, then greater up to infinity. So we are using this notation, then comma infinity. So we are using infinity, we use this type of bracket with it. So this, what you're having here like this now, we call it this like closed interval. This is like what closed interval. And this type of bracket here is what open interval. Exactly. So this is it. So that's the domain of this function. Let's look at another example. Let me say that you are asked to find the domain of this function. You have f of x to be equal to, let me say you have something like this, 1 over s squared minus x. 1 over what? S squared minus x. Now, how do we find domain of this function? Now, firstly, let me rewrite this function as 1 over, what am I having here? Factorize x out of this way. You have x bracket, x minus 1. Now, what is now the domain of this function? Now, remember that, check. If you are having a fraction, don't forget that what? For the fraction to be defined, your denominator must not be 0. For example, now, if you punch into your calculator, any number at all divided by 0, it will tell you that what? Undefined. So it means that what? For a fraction to be undefined, the denominator is what? Is 0. So it means that what the domain of this function? It is all value of x for which what? For which this denominator you have here, especially you see this x minus 1, this denominator you have here, for example, x bracket x minus 1 is not equal to 0. Are we following? The domain is that all value of x for which the denominator must not be 0. From here, it means that x must not be 0, and at the same time, x minus 1 must not be 0. So from here, x must not be what? 1. Now, check. So now write the domain. How do I write the domain? I can use different ways to write. I can use different style to write my domain. Let me use another way for this one. How do I write the domain of this? I'll use different style to write it. How do I write the domain? Now, check. The domain of this function, remember, all values for x for which a function is defined. And from here, we observe this denominator must not be 0. If it is 0, the fraction is undefined. Therefore, the domain is what? All values of x for which this denominator, x bracket x minus 1, is not equal to 0. So from here, we observe that what? X must not be 0 and x must not be 1. Check. If x is 0, this function is undefined. So how do we now write the domain? Now check. I'll say the domain is equal to a set of values of x such that x is not equal to 0 and what? X is not equal to 1. Look at another way. Using set builder form. This is one way. I can write it in terms of me using look at another way. You can also say your domain. This is another. You can also say your domain, okay, belong to this set. I can say check that. See, your answer, you see, you must not include 0 and you must not include 1. That's the problem. You must not include 0 and you must not include 1. That is check. I have my number line. Look at this number line now. This number line is 0 and 1. Please include every other thing on the number line, but don't include 0 and 1. Don't include 0 and you will see. It means that I can include all the numbers to the left of 0, and that's negative infinity, comma 0. You can see, if I'm using this type of open interval, it means that 0 is not included. But if I write something like this, minus infinity, comma 0, and I use this type of bracket, this closed interval, this shows that 0 is included. So this one will be wrong. So if you're writing that 0, you must use this type of bracket. It means that yes, 0 is not included. Then union, I want to include number between 0 and 1. What do I say? I'll use this bracket 0, 1. Since I'm using this type of open bracket, this open interval bracket, it shows that I'm not including 0, I'm not including 1. Also, you can include number to the right of 1, which is what? Union, check, 1, positive infinity. And this is the domain. So you can write your domain this way or your domain this way, whichever way is correct. Are we together? So, comment, is there any question?
No, sir, I understand everything well.
Very well, exactly. You can see, so domain can come in any way. So just understand the pattern of how we write domain. So it's very easy. It's very easy. Give me a second, please. Probably. Nice. So we move on. Okay. So that's about domain. Okay, let's go. Now there are some terms that you can come across. What do we call even and odd function? What do we call even and odd function? What do we call even and odd function? Do you know about even and odd function?
No, sir.
Okay, check it out. See what we call even function here. You see, if a function is even, then you see that f of negative x will still give you the same thing as f of x. This function is even. And if your f of negative x is the same thing as minus f of x, this is odd function. This is how we know them. Just check the condition, that's all. Even function, f of negative x is the same thing as f of x. And check. Okay, let's do something. Let's do something real quick. What is cos minus 60? Use your calculator. What do you have? Cos of minus 60 is what? Like, put the minus inside the bracket.
0.5.
0.5. Okay, check. What's cos 60? Remove the minus in the bracket. What do you have? What's cos?
Still 0.5.
This is 0.5. It means that, check, f of minus x, f of x, they are the same. So cosine function is an even function. Let's look at sine, whether sine is even or odd. Now, what's sine 30? Sine negative 30. Sine negative 30.
Okay. Sine negative 30. Okay. That's minus 0.5.
Minus 0.5. And what's sine 30? We know that one is what? 0.5. Mean that for me to make them the same, I'll have to put a negative sign, which means that f of negative x is minus f of x for sine. So sine is what? An odd function. Okay, now looking at this, don't worry, I'll give you the notes. Like all this thing, I will print it out for you. So I'll just send it to you. Okay, looking at this one now, if I have f of x is equals to x to the power of I'm coming x to the power of, let me say something like this. Let me say h of x is equal to 2x minus x squared. And I ask you, is h of x even or odd? Is h of x even or odd? Is h of x even or odd? Okay, let's go. Firstly, this is what you are going to do. You see that this is what you have. This is how you are going to attack the question. Just find h of minus x. Your h of x is 2x minus x squared. So therefore, find h of minus x. That is, wherever you see x, put minus x. So you have minus x minus what you have here. You have minus x, then square. So wherever you have minus x, just input minus. Wherever you have x, just input minus x there. So what do you have? Check. Minus 2x minus what you have here is what? This should still be positive. If you have minus in the bracket and your power is an even number, the minus will change to plus. So this is what you have, x squared. And check. Check what you have. Now check what you have here. H of minus x. If you check, my h of minus x, if you observe, is the same thing as factorize minus outside from here. What do you have? 2x Hello, all together? Wait,
Yes.
hello. Are you following?
Yes, sir. I understand what I'm
Yes, sir.
following.
Exactly. Now check, is this h of minus x even or odd?
It's
Or
it's
you
odd.
cannot classify it as even or odd.
Um, I can't classify it as even or odd because this h of x will be equals to. No, I can't classify it. I don't know.
Exactly. Okay. As if, because if you check, our h of x is not something as minus h of minus x. Do you understand? Okay.
Yes.
Let's look at this one. Exactly. Okay. I'm coming. Let's look at something like this. I needed something like this. Okay. Let's say if you have, okay, look at this. G of x is equals to 1 minus s to the power of 4. Now, let's check if this g of x is even or odd. Yeah, let's go. G of minus x is what? 1 minus x to the power of 4. So what do we have? This will be 1 minus, what do we have? S to the power of 4. Still the same thing, Abi now. So
Yes.
since your g of x is the same thing as g of minus x, so what do you say? This function is what? Even function.
Even.
And so on
Okay.
like that. So that is. So let's look at composite function. Composite functions. From the word composite function means that those functions are inside one another. Like we are having one function inside another, Okay. Now, pay attention. We know composite function. Let's say you have two functions that is given two functions, f and g. You see composite function. Composite function, you always see them as this. Check. You always see them as g of f, or you see them as f of g, and so on like that. So check, what's the meaning of f of g of x? What does that mean? It means that you are to put g of x inside f. So this means you are having f of g of x. That's the meaning. So if you see f of g of x, it means that you have to put you are supposed to put g inside f. Let's look at another one. See, at times, okay, let's look at this question. Check this question out. Let us first start with simple question. F of x is square root of x, and g of x is square root of 2 minus x. And I ask you to find, okay, the first question is that you have to find f, okay, let me say f of g. The second one, you have to find g of f. And the third one, you have to find g of g. Okay, let's solve that. Solution. So what's f of g? Don't forget. F of g is saying now f of g of x. And what's that? How do we do that? How do we do this? Now, we are to put, therefore, our f of g is equal, we are to put g of x inside what? Inside f of x. That is, wherever you see x in your f of x, you'll be putting it as g of x. All together? That's just what you're going to do. That is, check. My f of x is square root of x. But instead of me writing x, it's just like check. What I have initially is f of x. Now they ask me to find f of g of x. There's no problem. This thing means that replace x with g of x. Just replace x with g of x. That's all. So whenever you have x, just replace it with what? G of x. And what does that mean? Square root of what? Square root of 2 minus x. Do you see that? Do you understand? Do you understand this part?
Yes, I get it very well.
Exactly. And that's what? 2 minus x. That's 1 over 4. Raised to the power 1 over
Yes.
4. Another one, you have g of f. G of f means g of f of x. So therefore, my g of f is what? Now, remember, I have g of x. They have to find g of f of x. So just replace what you have here. So just replace it. What do you have here? Yeah, let's replace. Let me leave it. So what do you have? Let's replace. So I have, what's my g of x now? Square root of 2 minus x. Now my x has been replaced with what? F of x. Are you there?
Yes, sir.
Nice. So let's go. Square root of 2 minus my f of x is now what?
Root x.
Square root of x. That's it. So just replace x with. And the last one, g of g. G of g. What's g of g? That's a g of x. So let's go. It means that what's my g of x? Square root of 2 minus x, have you?
Yes.
2 minus x. Instead of me to write x, that will be g of x. So let's go. That's square root of what? 2 minus
square root of 2 minus x.
Exactly, that's it. As simple as that. So this is the simplest part that you can see. Okay, let's look at something that is more tougher than this. That's example 1. Example 2. If you have some of your lecturer's question or the one you have not been able to solve, you can bring it to yourself, solve it live for you. So f of x is x over x plus 1. And g of x is x to the power of 10. H of x is x plus 3. Now the question is, you have to find f of g of h of x. That's the question. Okay. Should we move on?
Yes.
Okay. So what do we first? Let me interpret this thing for you. You see this f of g of h of x. What does that mean? It means that you have to find f of, g of h means g. I'm coming. Like you're asked to find something like this. F of what do I write? G of h of x. That is, you have to put h inside g, then everything you now put inside f. All together?
Yes, I get.
Exactly. So what do we now do here? Yeah, first let's find our g of h of x. G of h of x is equals to what? Oh yeah, what is my g of x? Sorry, what's that my g of x? Write it down,
X
please.
to the power 10. X raised to the power 10.
That's my g of x, right?
Yes.
G of x is x is power 10. Good. So it's not me to say s is power 10. What will I say? I'll say what? H of x is to power 10. Are you there?
Yes.
Exactly. So what's now my h of x?
That's x plus 3.
That's x plus what? 3 to the power of what? 10. Let me check this here. I'm coming.
H of x in g.
Exactly. X plus 3 is power 10. Yeah, that's correct. So that's our answer. Now, no, that's not our answer. Sorry. Now we have done that. So let us now find f of g of h of x. Let's go. What do we have? Instead of me to write this x, what will I say? I'll say what? What will I say there? I'll say my g of h of x. Are you there? Plus 3 to the power of. I'm breaking. People will not break it down for you like this, but I'm just breaking it down in case you are confused. All together. Okay. That wherever you see x, you just replace it with the whole of this. That's all. Okay.
Sorry, sir. I'm confused though.
Okay, let's go. Let me explain something for you. Let me explain it again. Check. Normally, let me tell you something. What do you normally write before? Shebi, you know it's f of x. Good. Then I ask you to find f of g of h of x. Firstly, we start from the inner bracket. We found f of g of h of x, and this is it, Abina.
Yes, we found g of h.
It's very simple. So it's very simple. In your this thing means that in your f of x, replace it with whatever you get in your g of h of x. That's all. Normally, f of just replace what you have, just replace it. Okay. And remember, what's my f of x initially? What's my f of x?
X over x plus 1.
X what?
Over x plus 1.
Exactly. You know this is my f of x. Then I say find f of g, you know that f of g of h of x is like me saying f of x plus 3 raised to power 10. You know?
Yes.
Exactly.
Okay.
So this thing, what does it mean? Just replace. That's all.
Okay.
Exactly. Exactly. Hey, anyway, you can just get it. So just to do it in a simple way. Yeah, let's go. What's my g of h of x? This is Tabina.
Yes.
Remember, I'll replace. Don't forget to. Don't forget. Wait, I'm coming. Wait, hold on. Wait. It's like there's a slight mistake somewhere. I'm coming. Wait. It's because I did not write this thing down. I'm coming. Let me write it down. What's my f of x? Call it out. This is Abi.
X over x plus 1. Yes.
Exactly. So remember, my f of x is x over x plus 1. Now, pay attention. I want to find f of g of h of x. Abina. Another bracket. Good. And what does that mean? It means that wherever I see a hand, this I should be. Wherever I see x here, I should replace it with what? G of h of x. Abina.
Yes.
So I have g of h of x all over g of h of x. Abina.
Yes.
So what do I have here? What's my g of h of x? What does that give me?
X plus 3 raised to power 10.
10. Good. All over what? X plus 3 raised to power 10 plus what? 1. Right? Exactly. So this is my answer.
Okay.
Yes, that's how to do it.
Got it.
Yeah. I'm coming. Let me see if I can get some question. I'm coming. Yeah, I'm coming. Let me get, so I can just give you one. Okay. Exercise. Give me some second. Okay. Almost there. Okay. So looking at this question, I'll not give you simple ones. Okay. Firstly, look at this question. You have you want simple hard question.
The one that the exam will ask.
Okay. The one that is realistic for exam, exactly. That's good. Okay. Now let us start with this. So find the domain. You have to determine the domains of the functions. Okay. So this is the domain. This is the function. Let me just give you two. So the first one is y equal to x over x squared plus 4. And the second one is y equal to 1 over x minus 2.
Okay. Let me just do this. X plus 1, x plus 2. Oh, Jesus Christ. Okay. So for that first one,
Okay.
X plus 4 is not equal to 0. So when I did it, I got that x squared is not equal to minus 4.
S
Then this
plus
both
4
sides
must not be equal to what?
0.
0. Okay. Then what again?
So then x squared is not equal to minus 4.
Okay.
But I don't know. The square root will be negative. I mean, the number is going to be negative. If I have
Okay.
x will not be
Wait
equal to
to
square
wait to.
root.
Let me just follow all your answer. Don't worry. Let me just follow what you're saying. Now, so check. Let me just follow your pattern. I'll not show you something. So this is what you have minus 4, right?
Yes.
So check. If I say x must not be square root of minus 4, is this a real number?
No, it's not.
For this thing not to work, our value is going to be a complex number. And are we looking at the complex number here?
No.
It means that this domain is true for all real numbers. Are we together?
Okay.
Check. Just guess. Is there any real number you put here that will make this denominator 0? There's no real number. Are we together?
Okay.
Good. What do you now say? The domain is what? How do we write set of all real number? You can say from minus infinity to infinity set of all real number. Or you write it in words. Are we together?
Yeah.
That is, yes. So since I can say this way, I can say since x squared plus 4 is not equal to 0 for all x, since x plus 4 is not equal to 0 for all x, there's no s you put it that'll make it 0.
Yes.
So since this one is not, do we know if this thing means for all x? Are you there? For all.
Yeah.
Since this one is not equal to 0 for all x, then what do we say? You say, well, the domain is the what? Is the set of all real numbers. Of all real numbers. I can write in different ways. Because I can say, okay, the domain, this is another way, is equals to a set of x, so that x is a real number. Anyway, everything is correct. Okay?
Yes, sir.
Exactly. This is the first one. Now, what's the second one?
Second one
You
is
can see how this first one is tricky. That's what I'm giving you. So these are like likely exam questions that you can see.
okay. Second one, okay, wait. So it's not equal to 0 equal to 2. So the domain for that one is just not equal to 2. Wait, I'm coming. How do I write it now? Minus infinity to. So there'll be an open bracket.
Okay.
For the second one. So I have minus infinity. Then comma 2.
Okay.
Then I'll close the bracket. That's the.
Okay.
I'll close the bracket.
Remember that.
Then,
this one is that. Hello. Okay. Have you gotten your answer?
yes, I'm saying it already.
This one, the domain is what? Remember, x minus 2 must not be 0.
Yes, x must not be 2.
Must not be 0. Therefore, x must not be what? 2. So how do you now write the domain now? You will see. People write in different ways. Yeah, tell me, how do you want to write your domain?
So I will write wait though. I'll open a close bracket that's a close circle bracket or something.
Okay.
Not the square bracket. Then I'll write minus infinity, yes.
Minus infinity,
Then comma 2.
Comma 2.
Yes. Then union.
Okay.
2. Comma plus infinity.
Nice one, correct.
Yeah.
In fact, the best way to even understand that, just do number line, put 2, put anything here other than 2. That's all. And the first one you wrote here, this is it. Then did the second one.
Yes.
What was that? That's the way. You can write it in different ways. Some people, different ways, but I believe you can understand those ways now, right?
Yes, sir.
Okay. That is about domain. So next one is finding the range of a function, right?
Yes.
Okay. So let me go to the next page. Now, remember that if I say f of x equal to y, remember that I can also say f inverse of y is equal to x. Do you know that?
Yes, sir.
Exactly. Now, remember that, you see, this x that you are seeing here, It's called the domain. What did I say? X that we are seeing here is called the what?
Domain.
Exactly. That's those elements in the first set. Yes. You see, there's difference between domain and codomain and range. Let me quickly tell you here. Pay attention. Let me say I have 1, 2, 3, 4. Let me say I have 4 and 16 here, for example. If I map, I'm coming on. Let me say this is to this, and let me say this is to this, for example. And let me say I have 9. Let me say this to this. Let me say I have 1. Let me say this to this. And let me now say I have 25. See, every value you see here in the first set is the domain. Every set you see here is the codomain. But what is the range? The range are those one. The range are the image of the domain. That's all. The range are the image of this. That is 1, 4, 9, 16 are the what? Range. Are you together?
Yes.
Exactly. So everything here, including what was mapped and what was not mapped, is your codomain. Do you get that?
Yes, sir.
Exactly. Now, so see what you have. Now, do you know that if I tell you that, check some facts here. Let me tell you some facts. Do you know that from this thing, I can say the domain of F inverse is equal to the range of F. Now, pay attention. Let me ask you something. What is the domain of F inverse? What you remember? I told you that F of X, S is my domain. Have you now?
Yes.
And Y is the range. Let me write it there. This is the domain. Have you now?
Yeah.
And this is the what? Range. Oh yeah, tell me what the domain of F inverse here?
That's Y.
Also, this is the domain. Don't worry. Let me write it there. And this is the what? Range. Oh yeah, tell me what is the domain of F inverse? What did you see here?
Y.
And what's the range of F?
Range is Y.
Exactly. So do you get that point? Because
Yeah.
I can do all those objectives for you, and that people will be failing it because they don't really have to understand. Yeah, check. Also, if I tell you that range of F inverse is equal to the domain of F, is that correct?
Sorry, can you just wait? Let me just try and process this thing.
Okay. Don't worry. Let me tell you, you don't have to process at all. Whenever we say G of X is equals to Y, whatever you have inside your bracket is your domain. And whatever you are having here as the answer is your range. Okay?
Okay.
Good. Now, what are we having in our brackets? I just labeled it as domain. Are we together?
Yes.
And our answer here are the range. Are we together?
Yeah.
So yeah, now look at our function F. We have two functions here. One is F, one is F inverse. Now, what do they have in common? They have this Y in common, Abina.
Yeah.
Because the range of our F was the same as the domain of this F inverse. Do you see that?
Yes.
Exactly. That's what I was saying.
Okay.
Also, the domain of our F was same as the range of F inverse. Do you see that?
Yes.
Exactly. So how do we now find the range? You remember that our domain is the value of X for which a function is defined. Abina?
Yes.
The value of it. Yeah. So what about range? How do we talk about range? Then that range will be talking about what? Y. Are we together? The value of function for which what? For which Y is defined. Are we together? Okay, good. Let us now look at something. Let's look at okay, let me just find what will not stress you like that. Okay, let's go. Look at this function. I say F of X. After this, remind me to give you a pile of questions.
Okay.
Minus X squared plus 1. You have to find the domain. You have to find the domain and range. So how do we get the domain and range? Okay, let's find the domain sharply. You check. What's the domain?
Domain.
Yes.
Domain.
of this. Is there any value of x that will not make? This is not a fraction. This is not a square root. Nothing. Any value of x can work here. Are we together?
Yeah.
So what do we say? So the domain.
All real values of x.
Yes, exactly. All set of real number. Exactly. All set. Or you say all set of real numbers. Exactly. Now, what is now the range? Now, just say let our y. To get your range, you can just say let y be equal to minus x squared plus 1. All together?
Yes.
And remember, x squared will be equal to what? 1 minus y. And my x will be equal to square root of 1 minus y. So what are the values of y for which x is defined? That's your range. That's what they're asking you for range. In the same way you find domain, but for range, we are centering on y. Now tell me, the value of y here must not be, check, 1 minus y must not be equal to 0. Must not be equal to what? Must
0.
be greater than.
Greater than
Exactly.
or equal to 0.
So thank you very much. That is the range. Must greater than or equal to 0. It means that, what do we say? It means that what? Oh yeah, what do we say? If I bring minus y greater than or equal to, what do you have here? Minus 1, Abi? Multiply by minus
y
2.
less than
Y
or
is
equal
less than
to
or equal to 1. So it means that what is now my range? My range is what? Oh yeah, what do we say? Remember, y must be what? Less than. It means that it is from year to year.
From minus, no, from
Negative infinity, comma what? 1. Did you see?
Yes.
These are my range. The values of, if y, for example, now let me say, let me say y is not greater than 1. Let me say y is like 5 now, for example. This thing will never work. So these are the values of y for which x is defined. It works. Another way we can write it is what? Do you have any other way?
No.
Yes, so I can say the range. You can see, look at another way now. It's a set of y such that you can see semicolon or you see a line like this. It's still the same thing. Y such that y is less than or equal to 1. This is another way. All of them are still the same thing. But be familiar with this interval notation very well. So this is how to find domain and range and so on like that. They are really simple. So there are many of them. Okay, there are many of them. Yeah. I think, have I taught how to find inverse of a function? No. So inverse is the last one we are finding. Now together?
Yeah.
Then after that, are you tired?
No.
You sound like you're tired. That I've not even given you that question. Okay, let's go. So yeah, we want to learn how to find inverse of a function. So let me waste your time. How do you find inverse of a function? Oh, and I need to teach you something here. I talked about inverse here, which is like something like this. You see, this, if I say, let me write it. If I say, if you hear anything like f inverse of x, please, this thing is not the same thing as 1 over f of x. So this one is not like law of indices that. You understand?
Yes.
Please take note of what I'm saying. Because some people have known maths too much in the year that they just gonna perform on magic. Okay. So how do we find inverse of a function? How do we find inverse of a function? Inverse of a function. How do we find inverse of a function? What are the steps of finding inverse? Is that firstly, okay, let me use a question to explain for you. Let me say we want to find the inverse of, let me say we want to find the inverse of this. Let me see, we want to find the inverse of x plus 1 over 2x plus 1. And the next one is s cubed plus 2. Now, let's see how we can find the inverse of this. Check. I can say, firstly, I can say, let y be equal to x plus 1 over 2x plus 1. That's it. You want to find the inverse of these functions, f of x. So just say, let y be equal to that function. Now, what's the next thing after that? Is that make your x the subject of the formula. Are we together?
Yeah.
So what do we do here? Cross multiply. So what do we have? We have 2xy plus y equal x plus 1. Abi now, make x the subject. So I have 2xy minus x equal 1 minus y. Factorize x out. 2y minus 1 equal 1 minus y. Therefore, my x is equals to 1 minus y over 2y minus 1. Then after you have made SL to the formula, what do we now do after that? Then replace your x as f inverse of x. All together?
Yes.
Then where you see y here, replace it as x. This is the inverse of that function. As simple as that. Replace your x with x inverse. Then your y replace it as x. And that's all. Okay. Another one, which is the second one. Let me do it a B. Let y is the same step. S cubed plus 2. The next one is that make x the same to the formula. Then the inverse of the function, f inverse of x, is cube roots of, replace y with what? X minus 2. Yeah, done.
Okay.
Yes, exactly. You can see it's simple. You have any hard question you have not been able to solve?
Not yet. I've not seen questions on this.
Exactly. Okay. Okay. All right. So that's that on that. Do you have any question?
No, sir.
In case you have, please, you can forward it to my DM. I will send this note to you and I will help you write out questions that you can lay your hands on. Okay.
Okay.
Yeah. So that is that about that. So let's discuss on our next class on WhatsApp.
Okay, sir.
Yeah.
All right.
Bye. See you.
Thank you.